Hello guys, so in the last class we had spoken about how to convert a wedge and dash structure into the Fisher projection, and why we were doing so that we can understand the configuration of the molecule. That means we have learned that we have chirality in the molecule only when the mirror images are non-superimposable each other. But how will we differentiate between those two mirror images? What we will call them, how will we give them a name? That's exactly what we want to know. And to know that, we need to know the Fisher projection so that it will be easier for us to determine the configuration of the molecule. So R and S is the configuration given to the optical isomers, which show the different which are non-superimposable mirror images, and basically which show different optical activities with respect to each other. So for R and S configuration, we needed to learn the Fisher projection so that it will be easier for us to basically determine the configuration in a 2D plane. We can do it in the 3D also, and we can do it in 2D also. So, but 2D is more easier to put it on the paper and then visualize and then give the right configuration to it. Now, when we are talking about RNS, I hope you can recall what we have learned in E and Z. So, we have done E and Z configuration in geometrical isomerism, and there we had done some set of rules to give the priority to the groups attached to the carbon. And then accordingly we have given the numbers to the molecules 1, 2, 3, 4, the attached molecules, and then we had decided whether the molecule is E or molecule is Z. So we will be using the same set of rules here to determine the configuration as R or S. Okay, so what happens here is, if you're talking about a molecule, in the molecule, if you see here, the molecule which is mentioned, I have a chiral center over here, and I have four different groups attached: A, D, E, and B. Right now, this molecule can have two kind of configurations. One is R configuration and another is S configuration. R is the short form, or you can say word, which denotes to rectus, and rectus means clockwise. Okay, similarly S is the word for sinister. Sinister means anti-clockwise. So we will be assigning the priorities to the group, and then we will seeing that whether it is going clockwise or anti-clockwise, and that will help us in knowing the configuration of the molecule. So here, when I have said that there are four groups present over here, A, B, E, and D, we will be assigning these groups the priorities. And for assigning the priority and marking them number 1, 2, 3, and 4, we have some set of rules. First, we need to understand those rules, and then I'll tell you how to apply those rules and how to define R and S. Okay, and then I'll show you with respect to 3D system also that what exactly R and S means. So first we will see the CIP rules. I'll quickly reiterate for you. I have written it over here, and then I'll explain you how to use these rules. So as I am expecting that you guys would be knowing most of these rules, because the same set of rules we have used for determining E and Z configuration and geometrical isomers. So here, what is the first rule? The group with the higher atomic number is the senior. So when you're talking about, I'll start explaining also parallelly. So if I have, let's say, chlorine, fluorine, bromine, and iodine, the one which has the highest atomic number, that will be given the highest priority. And the following, so we have iodine, then bromine, then chlorine, and then fluorine. So that's how we have given the priority in the molecule. Next is, in case of same atomic number, go to the second and third, and so on till the first point of difference. What do we mean? We mean, if I have, let's say, this kind of compound, I have H, I have CH3, I have C2H5, and I have COOH. So now here, if you can see very clearly, three groups are made up of carbon only, right? So the first atom which is attached to the center carbon is carbon itself. So on the basis of carbon, we cannot say whether the group is first priority, second priority, or third priority. So we will have to see the next point of attachment. So if you'll talk about this carbon, the next point of attachment is hydrogen. If you talk about this carbon, the next point of attachment is carbon. And if you talk about this carbon, the next point of attachment is oxygen. So which has higher atomic number in this case? This has a higher atomic number. COOH has the higher atomic number, because we are not checking the carbon over here. We are checking the next point of attachment, where the point of comparison is hydrogen, carbon and oxygen. So out of hydrogen, carbon and oxygen, your oxygen has the higher priority. Hence this group will get the first position or first priority. This group will get the second priority, and this group will get the third priority. So we will keep checking till we get a difference, and wherever we will get the difference, there we will start comparing, and we will mark the priority 1, 2 and 3. So next rule is, in case when the first and second atoms of the groups are connected with each other through the multiple bonds, then we resolve each and every bond like as if there are multiple single bonds present. What does it mean? Let me just show you. So let's say if I have in the carbon, let me just show you. I have CH3, I have hydrogen, I have C triple bond N, and then I have C2H5. Okay, let's say these are the four groups. How will we resolve the C triple bond N? How? Because there between the first atom and the second atom we have triple bonds. So the resolution of this C triple bond N is, I will treat each and every bond as a single bond, and the carbon what I have here is connected with nitrogen with three bonds. So I will make three individual single bonds with nitrogen rather than writing it as triple bond. Okay, and the nitrogen also is connected with carbon with three bonds. So basically I will be treating it as every single nitrogen is connected to three carbons further. So this is how it will be: this, 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 this and this. So see how I have resolved it. So this C triple bond N has been resolved in such a manner that all the triple bonds have been opened up, and we have taken them as a single bond connected to one atom. Here all the three bonds were connected to one single nitrogen. There we have individually placed nitrogen as different nitrogens. So one nitrogen here, another nitrogen here, third nitrogen here, and because nitrogen was also connected to the carbon with the three bonds, now on each nitrogen we are seeing the connectivity should be with the three carbons. So that's how we basically resolve it. We hypothetically consider that they are connected twice or thrice with each other. So we open the structure. Similarly, if I have, let's say, C double bond O, how will I write it? I will write it as if the carbon has made two bonds with two individual oxygens, and then oxygen must be connected to two different carbons. One is here and one is here and one is here. That's how we'll be solving. It will help us in comparing generally in those cases where, let me just show you, if I would have taken CH2 and H2 here. So in these two structures, C triple bond and in CH2 and H2, the first thing which we will check is carbon. It is same, so we cannot compare. Second atom we will check is nitrogen. Here also we have nitrogen, so we cannot check. The third element which is present along with the carbon is hydrogen. In this case, third atom is hydrogen, whereas in C triple bond N, my third atom is still nitrogen. So now there will be a point of difference. In CH2 and H2 I have hydrogen as a point of difference. In C triple bond N I have nitrogen as a point of difference, and hence this will get the highest priority. So this will be 1, then 2 and then 3. So that's how we visualize, we open up the bond and then we simplify it, and that's how we basically give them the priority. Okay, now in case of isotopes, next rule is, if we have isotopes present, then the heavier one is the senior one. Let's say if I have the structure like this, if I have a structure like this and I have D, T, H and Cl, let's say. Okay, so I have chlorine obviously as the first priority, and apart from that I have hydrogen, I have D, that is deuterium and tritium. So now among these three, which one will be taken as the highest priority? The T will be taken as the highest priority, so it will be 2 and this will be 3. So basically the heaviest isotope will get the preference or will get the higher priority. Next, we can have the lone pairs also as the groups, and if the lone pairs have been taken as the groups, then their atomic number is considered to be 0, and hence they'll be the least preferred group, or you can say the junior most group. So I'm mentioning this again. If we have the lone pair as one group in one of the attachments, then that has to be given as the lowest priority, because we will take its atomic number as 0. So now we have got the rules, and now we have to see how to implement these rules. Okay, now implementation of the rules, as I mentioned, first of all you have to understand that R means clockwise, and S means anti-clockwise. So whatever I'm saying, that these two things you have to remember right now, and you have to forget it after some time. I'll tell you why we have to forget it. Now I'll take some example. Let's say I have taken this example as COOH, hydrogen, NH2, and CH3. So I've taken this example, and now what we are doing is we have to give the priority. So which one will get the lowest priority, which one will get the highest priority, I'm sorry. This nitrogen will get the highest priority, then comes your comparison between COH and CH3. So COH will get the higher priority, then my CH3 will get the higher priority, and the least is with the hydrogen, right? So now when you look at this molecule, I have 1, 2, and 3 like this. So now you have to visualize this molecule in the normal 3D representation. So this is my molecule. Okay, this is the whole thing. This is your COH. Here is your CH3. This is your CH3. NH2 is at your left. So this is your NH2. I'm showing it as you are the viewer. Okay, so this is NH2 and this is hydrogen. So that's how the molecule is. All of you please look at it very carefully. I hope all of you can see this. This is your COH, this is your CH3, this is your hydrogen, and this is your NH2, right? Now what did Fisher say regarding marking the R and S for such molecules? We have hydrogen as the least priority group. So whenever we have to mark R and S configuration, what we have to do is we have to push the least priority group at the back, so that other three groups to which we have given priority 1, 2, and 3 can come in front of the viewer. This is my least priority group. This is my hydrogen, right? So what we'll do is we'll try to push it at the back. We'll try to push it at the back. Now see, the priority 1, 2, 3. Priority 1, 2, 3 molecules are visible to you, and the one which had the least priority has been pushed back. Now look at it. This is your COH, this is your NH2, this is your CH3. Okay, this is priority 1, this is priority 2, and this is priority 3. So how is it moving? Just tell me, how is it moving? What kind of movement, what kind of rotation is it from 1 to 2 to 3? Like this. So what kind of movement is it from 1 to 2 to 3? It is anti-clockwise. If it is anti-clockwise, what should be the configuration? Configuration should be S. So for this molecule, the configuration is S. Okay. So see here. So we will write S as a configuration for this molecule. Correct. Now let me take another example. If I have a group COOH, hydrogen, OH, and CH3 like this. Now again I'll mark the priorities. This is my priority 1, this is my priority 2, this is my priority 3, right? And now again I'll take the 3D structure, and again I'll show you the same thing. So this is my molecule. Okay, this is your COH, this is your CH3, this is your hydrogen, and this is your OH. Am I right? Yes, I'm right. Okay, now what we have to do, we have to again push what? The lowest priority group. Which one is the lowest priority group over here? Hydrogen is the lower priority or lowest priority group over here. So what we will do with this hydrogen? We'll push it at the back. Let's push it at the back. So now what all we have? We have COH, we have CH3, we have OH. So this is 1, this is 2, this is 3. Like this. What is the rotation over here? The rotation is clockwise. So that means the configuration for this molecule is R. Okay, so these are the two which I have shown it over here, and I have explained it with the 3D structure, with the wedge and dash. Similarly, if you see a molecule like this, let me just show you the wedge and dash representation also. If let's say I have a molecule, say COOH, CH3, hydrogen, and Cl. Let's say this is the molecule. Now what we will do, hydrogen is already at the back, is away from the viewer, right? And these three things will be visible to the viewer. So here we will start marking the number. This is 1, this is 2, and this is 3. Okay, this fourth one is already behind the viewer, so viewer cannot view it. Okay, so now what we'll do is we will mark the configuration. The rotation is happening from 1 to 2 to 3. So 1 to 2 to 3, what kind of rotation is it? it is clockwise. So the configuration is R. So if you get a 3D structure, if you get a wedge and dash, it is very easy. When you talk about the Fisher projection, then we will be using a trick, because not every time you will be carrying this to just convert it into 3D and then see and move the rotation and this and that. So we have a very easy trick to see how to push the fourth priority one at the back and then bring the 3 in front of you and then see the rotation as clockwise and anti-clockwise. But for that, what we have to do is we have to forget that R is clockwise and S is anti-clockwise. We will be solving it with a very quick trick over here. Okay, so let's see what's the trick. So what's the trick? Trick is, first note down, first write what has been written over here, and then we will discuss. So it's like if the fourth priority group is on the vertical line. So let's say if I have taken the molecule like this, and if I have hydrogen over here, COOH over here, OH over here, and CH3 over here. Assume this is my compound. Then I already know that my hydrogen is on the vertical line. If I'll number the priority, this will be 1, this will be 2, and this will be 3, right? So then what we have to do is we just have to hide this hydrogen. We just don't have, we have to assume that there is no hydrogen at all, or we have to assume there is no group at all, and then we have to just go from 1 to 2 to 3. So 1 to 2 to 3. What kind of rotation is it? It is clockwise, right? So if the rotation is clockwise, then we will name or we will represent it with the configuration of R. And if the rotation is anti-clockwise, then we will represent it by S. So this is very simple rule. This is only applicable when your fourth priority group is on the vertical line. Vertical line is this line. Okay, vertical line is this way. Okay, now let's say next, what does the next rule says? Next rule says if the fourth priority group is on the horizontal line, then what happens? Let's see. So if I have, let's say, hydrogen over here, and then COOH over here, CH3 over here, and OH over here. Okay, so what we are going to do over here, we have OH, we have hydrogen, we have COH, we have CH3. First of all, we'll mark the priority. This is priority 1, this is priority 2, and this is priority 3. So what we'll do is, again we will ignore the fourth group, we will hide the fourth group, and we will move from 1 to 2 to 3. So we are going 1 to 2 to 3. What kind of rotation it looks like? It is anti-clockwise, but mind it, if the rotation is anti-clockwise when the lower priority group is on the horizontal line, then mark it R. So this is also R. Okay, and if it is clockwise, then mark it S. So basically now we are not associating clockwise with R and anti-clockwise with S. It basically depends upon where your fourth group is present. This is just a trick. This is not the actual thing. This is just a trick. If you'll actually see this molecule in a 3D representation, this molecule would be giving you the one which is anti-clockwise and giving you R configuration would be actually giving you the clockwise rotation and the R configuration, but this is just a trick to see it in the Fisher projection. Okay, so that's how we basically figure out the configurations. So if you say this molecule and this molecule both are identical, because both are representing the R configuration. Now let me show you how these are identical. So I told you, I'll just write it here. I'm writing it pretty tiny here. H, COOH, OH, and CH3. And now what I have here is H, COOH. So this is basically, I'm covering up the another concept which we had learned in the previous class. So these are the two compounds. Okay, so what have I done? I have taken this COOH, hydrogen, CH3, and OH. Correct? Now to get the second compound, what can I do is I can switch the position of hydrogen and COOH. If I'll do that, my hydrogen will come here and my COOH will come here, but my other compound has hydrogen on the other side, right? So there what I'll do, I will shift here also. So basically two switches I have done. First I have done with hydrogen and COOH, and next is with hydrogen and CH3, and I got the second molecule. And that is what exactly I explained you in the last class that when you do double switch or even number of switches, the configuration of the molecule doesn't change and the molecule remains the same. So it is identical. These two compounds are identical. We will talk about these compounds and these type of compounds and these switches furthermore. But now let's try out some more questions and understand whether we have got these rules properly or not. So let's see this example. What we have done, I have taken the example where I have COH, NH2 and CH3. I have marked the position 1 for NH2, 2 for COH, 3 for CH3, and if I'll see the rotation is coming clockwise, but my hydrogen is present on the horizontal line, hence the configuration is S. Now look at this molecule. This molecule has 2 chiral centers, so I will have to individually find out the configuration for these. So how will I do it? First, this carbon I'll take. So this carbon has COH, hydrogen, OH, and this whole group over here. So I can write it as CHOH, right? This is COH, H, and then COH. So I can just write it CHOH like this. So first priority will be for OH, second priority will be for COH, and third priority will be for this group. How is it? Try it out on your own and you'll get it. So the rotation is what? Rotation is anti-clockwise, but the hydrogen is present on the horizontal line, hence the configuration is R. Exactly same way, try out for the down one. I have OH, H and COH. This is 1, this whole other group is there, this is 2, and the whole other group is 3. So when I'm moving 1 to 2 to 3, this is going what kind of rotation? This is anti-clockwise rotation, and again my hydrogen is present on the horizontal line, and hence the configuration is R. I'm not very sure whether you have got it or not, but we'll do many questions and you will get much better clarity in those. So let's go for the examples now, more examples now. So here is the list of examples. Let's try out whether whatever we have learned we have got it properly or not. So let's start marking. Okay, so this is my OH is priority 1, COH is priority 2, CH3 is priority 3, and if I'll move from OH to CH3, this is anti-clockwise rotation, but hydrogen is present over here on the horizontal line. Whatever is clockwise is S and whatever is anti-clockwise is R. So what is it? It is anti-clockwise, so it is R. Okay, exactly same way, look at the other one. This is priority 1, this is priority 2, and this is priority 3. So it is going clockwise, correct? This is going clockwise, hydrogen is on the vertical line, so clockwise and vertical line, it's R. Look at the third one. I have the first first priority as CH2Cl because first point of difference is chlorine, then comes your CH2OH, then comes your CH2CH3. So 1, 2, 3 like this, anti-clockwise, and the lowest priority group is present on the vertical line, and hence anti-clockwise means S. Try out these 4, 5, 6, 7, 8, 9, 10 on your own, and then we will see the answers. Please quickly try out on your own. I hope you guys are done, and now let's quickly discuss. So let's talk about the fourth one. In case of fourth one, what is happening? Look at it. So I have the carbon over here. The first point of attachment is carbon, which is same in all the cases. Second point of attachment is oxygen, which is same in 2 cases, so I cannot figure out 1 and 2. So I'll go for the third point of attachment, that is oxygen. So basically now the difference is one has oxygen and other has carbon, so this will automatically get the priority 1, this will get priority 2, and this will get priority 3, and I have priority 4 on the vertical line. So let's see how is it moving. It is moving clockwise, so the configuration is R. Similarly, look at the next example. I have OH as the first priority, then CN as the second priority, and CH2CN is the third priority, and I have a lowest priority group on the horizontal line. So if it is anti-clockwise, the configuration will be R. Look at the next example. OH1, COH2, CH3 3, and hydrogen as 4, and the hydrogen is the lower priority group which is present on the horizontal line. So the rotation is clockwise, so your configuration will be S. Now look at the seventh one. NH2 as 1, COH is 2, CH3 as 3, and hydrogen as 4th, and hydrogen is present on the horizontal line. So whether the rotation is clockwise, anti-clockwise, I have to check. This is anti-clockwise, so configuration will be R. Look at the next one. I have C triple bond CH. I told you how to resolve the C triple bond CH. You will be resolving it like this. Okay, so basically one carbon is connected to further 3 carbons, and each carbon will be further connected to okay, I have written it a little messy over here. I should have created a little more spaces. So it will be written as C C C H C C H H. Basically each carbon is connected to 3 carbons, and that's how we have to write it. Okay, so this is how it will be resolved. It's a very, again, it's quite messy, so if you want I can write it once more. Okay, so see, this is my carbon which is connected to 3 carbons individually, and each carbon is further connected to 3 carbons individually. This is how the resolution will be. Okay, and there is CH2, CH double bond CH2. So how will we resolve it? We will resolve it as C and C, and the C is further connected to 2 carbons. That's how we'll resolve it. So for when you compare between C triple bond C and CH2, CH double bond CH2, this is first point of contact, same. Second point of contact is carbon, again same. Third point of contact is carbon, again same. Let's move to the next attachments. Here this carbon has further attachment as carbon, whereas this carbon also has a further attachment as carbon. Go to the next one. The next carbon has further attachment. Okay, no, I think I missed it. So here itself the direct attachment was 2 were the carbons, and the third one was hydrogen. Here all the 3 are carbons. The point of difference is between hydrogen and carbon itself. I missed it, I'm sorry. So we didn't have to even check till very far. So this point of difference is not there. I mean, here this is same, this is same, this is same, and this carbon is same, but here there is a third carbon, and here we have a hydrogen. So here comes the point of difference, and which will take priority? C triple bond CH will take priority. So this is 1, this is 2, this is 3. The rotation is what kind of rotation is it? This is clockwise, and my group is present on the horizontal line, so the configuration is S. The configuration is S. Now look at the next compound. Next compound, again what we have, always remember that the triple bonded structures, if you're talking about the carbon, triple bonded structures will always have a higher priority than the double bond, because when you'll resolve it there will be one extra carbon attachment there. So basically unsaturated ones will always take the priority over the saturated ones. So if I have to compare between this and this is first, this is second, and this is third. Let's go for the rotation. If I'll go for rotation, the rotation is going anti-clockwise, and here is hydrogen on the horizontal line, so the configuration is R. Now let's talk about the next compound. Next compound has CH3, Cl, hydrogen, and then the other group. So chlorine will get the first position. Your other whole group, this whole group is going to get the second position, and this CH3 is going to get third position. So we are moving from 1 to 2 to 3 like this. This is clockwise. You have hydrogen over here, so it is S. Same thing you will do for the down one. Chlorine get first position, your this attachment gets the second position, and your CH3 gets a third position. So rotation is like this, which is what? Which is clockwise again, and the configuration is gonna be S. Why configuration is gonna be S? Because the fourth group is on the horizontal line. So that's how exactly we resolve R and S, and this is very important for the next phase of optical isomerism, because now we will start understanding, and now we'll start seeing the isomers and their activities and this and that. So for that, every time whenever we are talking about the isomers, optical isomers, we have to know the R and S configuration. I hope you would have got it, but just in case if you have any doubt in this case, especially in resolving the double bonds and triple bonds, ask me in the doubts class.